Hello, everyone. I am thrilled to be here. I'd like to thank LAF for your sponsorship and the sponsors who sponsored the fellowship. I'd like to thank Cohort 7. I have really enjoyed getting to know you all over the past year, and I'd also like to thank our advisors, Laura Solano, Cindy Sanders, and Danielle Carbonneau. I feel very lucky to have been through this year-long process, and I'm excited to show you the results. All right, during my fellowship, I've been working to facilitate substantive change in the site construction industry. I have always loved materials and details. I mean, who doesn't? They're tactile, they contribute so much to the way a place feels. But ever since 1999, when I wrote about my first article about the embodied energy of cement, I've grown increasingly concerned about the impacts that construction materials have on our environment and on our climate. Here are some key events that led me to this fellowship. In 2014, the Intergovernmental Panel on Climate Change published the 5th assessment report, which intensifies discourse around the planetary impacts of climate change and directly informed the 2015 Paris Agreement. In 2019, Pamela Conrad was in the second cohort of LAF Fellows. Her work led to the Pathfinder Carbon Calculator and the formation of climate positive design. In 2022, ASLA released the Climate Action Plan, which Pamela co-authored and I served on the advisory group for. The plan sets forth multiple goals, but the most key is to achieve zero embodied carbon and operational emissions and increase carbon sequestration by 2040. In the 6th cohort, Chris Hardy worked on scaling up the Carbon Conscience tool, and he established a lot of embodied carbon numbers for the materials that we landscape architects use, and they've benefited my project this year, and I thank him for that. But for the past 6 years, we have averaged a 1.4 degree Celsius increase in global temperatures worldwide. This is urgent. We can't have incremental change anymore. We need substantive change. I am truly fearful about what is happening to our climate. So I am building on Pamela and Chris's work with the intention to provide landscape architects with tools to meet the Climate Action Plan goal. I'm writing a book with the working title of Details and Materials for Resilient Sites, a Carbon Positive Approach that will provide a roadmap for low carbon site construction. During this fellowship, I have crunched the numbers and quantified just how big of an impact site construction materials have. Here's a parking space. We all know how big that is, right? And here is its carbon footprint. It's bigger than the parking space. This is a sphere 10 meters in diameter for a concrete parking space. 80% of the embodied carbon of a built site is from the construction materials used to build it. We cannot have incremental change. We've been working on that since 1999 or even longer. We are not going to meet the goals of the Climate Action Plan unless we have substantive change, unless we make a radical shift in our material specifications and detailing to decarbonize construction. There are a variety of solutions that we can use to affect substantive change. And these are the approaches that I'm covering in my book, and I'm going to take you through some of them this evening. The first is to reduce the embodied carbon of standard materials. We are always going to use concrete, and that's fine, but we can make improvements in the materials industry from the supply side. We can make improvements from the demand side by specifying lower carbon mixes. So what does this mean? And I'm a little bit picking on concrete because concrete is responsible for 7 to 8% of all global emissions. Remember our parking space. The industry has plans to decarbonize and achieve net zero by 2050. The Mission Possible Partnership has laid out a pathway, and the industries, various industries around the globe have done that as well. They're all very similar. The first is to optimize design, build smaller, more efficient structures, use the lowest strength concrete for the job. We regularly specify 4,000 PSI when we could be specifying 3,000 PSI for many structures. Using cement substitutes like fly ash, blast furnace slag, calcined clay, et cetera, or even alternative cements that are finding their way to market. The industry can capture carbon and make other process improvements, and then of course, they can use renewable energy. Other industries are making these improvements as well. This is just an example. The other thing is that there's so many concrete innovations on the market, and we love to read about them. The biogenic limestone, the self-healing concrete. These are great, and they are the future of concrete, but they're not readily on the market yet. So we need to do some things in the meantime. The next step is to use alternative materials and structures. Building flexible structures instead of rigid structures, using local materials and nature-based solutions. During this fellowship, I have compared the embodied carbon numbers for many site structures, pavements, walls, fences, guardrails, decks, etc. I've crunched a lot of numbers. In this example, I have looked at a 10-meter long retaining wall. And I included standard assemblies, imported granite on a concrete stem wall, a concrete retaining wall, compressed earth blocks, some alternative materials, gabions, and a live crib wall. I looked at the wall stem, the footings, the drainage behind the wall, et cetera, and crunched the numbers for these. These figures are for the cradle to gate phases of the materials. I did not factor in transportation to the site. Here are my results, and here's a little bit how to look at it. Along the bottom are all the structures, the granite veneer wall all the way over to the vegetated crib wall, and along the side are low, medium, and high for embodied carbon. And just to give you some context, the 3.3 tons of CO2 equivalents for the imported granite veneer wall, 3 tons, think back to our parking space example where a ton is 10 meters across. All right, so that's not the full story though, because we can look at ways to reduce the embodied carbon. For instance, if we use domestically quarried and worked granite, not domestically quarried and sent overseas and sent back granite, we can reduce the embodied carbon by 25%. If we use cement substitutes, we can further reduce it to 33%. And if we make just a thinner wall, if we do a 9-inch thick wall instead of a 12-inch thick wall, we get down to 43%. So we're starting to come in line. We can do the same thing with concrete. Using, you can knock 15% of the embodied carbon off just by using 3,000 PSI concrete instead of 4,000 PSI. That is the easiest fix in the world. I'm not saying build weak structures that are gonna fail, but I'm saying use the correct PSI, don't over-design. Using 50% cement substitutes brings it down further, and then all the way to 47% by using a 9-inch thick retaining wall instead of a 12-inch thick wall. We can even improve the alternative materials by using cement substitutes here as well. But the only wall here that's going to sequester carbon, that's going to store carbon, is the vegetated crib wall, and it will store 3 tons of carbon equivalents, a 10-meter length of wall. So the lesson here is that we can use standard materials, but we just need to change the way that we specify them with alternative mixes, smaller structures, local materials. All right, so in a few minutes, I'm going to tell you we need to move substantially toward bio-based materials. So I thought I'd show you a deck board comparison that I did. This is decking for a 9 by 12 meter deck with 16-inch joist spacing, and the deck board's sized for that span. You also see replacement factors, because not all of these deck boards are going to last the same amount of time. For a 30-year deck, we will have some replacements with some of these deck boards, and so those are also factored in with the embodied carbon. So here you see the embodied carbon of the three woods, the pine, the pressure-treated pine, the thoroughly modified ash, and the tropical hardwood are very similar. This doesn't count the transportation from the factory gate to the site. The tropical hardwood is coming to the US from South America or Southeast Asia, which is quite a long way. The fused bamboo, unfortunately, is coming from China, and because it's not currently produced in the US, although I wish it would, because it's a great product. This is the carbon that is stored in this decking. This decking can be considered carbon neutral or even carbon positive if the wood is harvested for the decking and new trees are replanted from the site where the wood was harvested. So that's entirely plausible with the pine and with the ash, but it's not going to happen with the tropical hardwood. It's just not. So there's a huge impact there. Stay tuned on the carbon stored story, because it's being discussed right now about whether it's legitimate to actually count the carbon stored in lumber and other bio-based building products. But most importantly here, we see the ecosystem impacts. And I've defined that as a combination of habitat loss combined with the likelihood of reforestation. To build our 9 by 12 meter deck, it's entirely possible that we could get certified lumber for the pressure-treated pine and the thermally modified ash. I'm not sure that we can trust certified lumber when it's tropical hardwood, because there is a lot of fraud in the industry, particularly in Brazil. But also, very little tropical hardwood is plantation grown. So to obtain our tropical hardwood, we would need to disturb 1.68 acres of rainforest. It's not that we need to cut down all the trees, it's that the tropical hardwood trees that we derive the lumber from don't occur that often in the rainforest. For instance, an ipe tree occurs on average of once every 5 acres. So that's why we need to cut down 1.68 acres. And even if we just selectively harvest the tree, studies show that the rainforest, when it loses its keystone tree, will decline within 5 years and become pasture land. So the other thing that we need to consider is the carbon sequestration consequences of that. When the forest is gone, our tropical hardwood deck will result in a net loss of 25 tons of carbon absorption each year. So not all bio-based materials are created equal. And I think that 4 of the 5 decking options are pretty good. Some you could say are better than others, depending on where your site is. But there's one option that we should be avoiding. Alrighty. The next approach is to decrease consumption. Since 2020, the anthropomass, the mass embodied in our built environment, has exceeded all of the biomass on our planet. We have just mined and built so much. We need to look at a circular economy, and we need to build smaller structures, keep structures in use for longer, and optimize them. We need to work toward the image on the far right. Right now we're in what I would call the re-economy. We reuse, we recycle, we feel great about it, but we still go back to the natural environment and mine it. 64% of our waste stream in the US is demolition debris. I would argue that we need to mine the built environment instead of mining the natural environment. And I'm going to say it again. We need to mine the built environment instead of mining the natural environment. Ideally, we'd keep this building whole, right? We wouldn't knock it down and crush it up. But if we do that, The landscape, the site and infrastructure construction is the place to reuse that material in asphalt, concrete, and aggregate bases. Another approach is just to use less material. Everything in the US is big. I was just in the UK for a couple weeks and seeing how much smaller roads, parking lots, et cetera are. We can build smaller structures, and if we do, we can reduce our resource use by 25% if we build to European standards. We can also reduce our cost by a pretty good chunk as well. All right, so many takeaways from this project. I've come to multiple realizations. We employ nature-based solutions to provide ecosystem services of flood mitigation, air pollution uptake, water quality improvements, et cetera. I believe that we can use nature-based solutions for site construction as well. We need to move into a bioeconomy with construction materials. After all, true sustainability relies on renewable, regenerative materials like wood, bamboo, and living structures. And they store carbon. But you might say, well, you know, a living crib wall doesn't belong in downtown Chicago. Well, yes, it does, and it should. We just need to make an aesthetic shift. And I would argue that we've made an aesthetic shift in our field in the last 3 decades to loving and embracing the weedy, shaggy-looking native plants, right? Can we embrace different structures as well? So I used this iconic landscape at the Dallas Museum of Art Sculpture Garden to explore this aesthetic shift a little bit. The current landscape, which, and I love Dan Kiley, he's my hero, I mean no disrespect, but I just wanted to explore this. The limestone veneer on concrete walls, the seat walls are also limestone veneer on concrete, the pavement is cast stone. What if we switched out some materials? We did gabions with reclaimed concrete slabs. We did Texas limestone quarry block. We did stabilized stone dust pavement. We would save 83% of the embodied carbon. And this is even better for everybody who loves the bottom line. It would be a 66% cost reduction also. This is a win-win. Embodied carbon matters. Trade-offs, material mixes, smaller structures. So if all of this has kind of felt like a head-spinning 15 minutes, all of this and more will be covered in my forthcoming book with Routledge. It should be out next spring, fingers crossed. And I'd like to leave you with a challenge. I'd like to challenge you to make one choice on a material mix or a structure that is substantially lower carbon. And then on your next project, make 2 choices, do 2 things that are substantially lower carbon. And let me know about your lessons learned and your success stories and even your barriers encountered. The time to substantially reduce our carbon footprint is now. And I look forward to seeing your low carbon work. Thank you.